Thank you for joining us today. My name is Thomas Lazzara, and I'm Director of Research and Development here at Meister Filtration Products. Today, I would like to present an improved method of characterizing ultrafiltration membranes, specifically in regards to our hollow fiber product line, SepraPor. Ultrafiltration is typically used in downstream processes, such as antibody purification, and continues to be an important bioprocessing purification element in many recent fields, such as mRNA vaccines and VLPs. Ultrafiltration also remains a critical purification tool in emerging cell and gene therapies involving viral vectors and lipid-based vectors. Ultrafiltration membranes are typically used for proteins, polymers, and liposomes, in contrast to microporous materials that are more appropriate for micron-sized cells. This is illustrated in the graph below, showing the pore size of UF membranes with a range from 5 to 50 nanometers. And this is in contrast to microporous membranes, which have a porosity that can go up to 1 micron. Two properties are used to characterize ultrafiltration membranes, which are permeability and porosity. Permeability is measured at the clean water, flux, and LMH per bar. Porosity is typically characterized by secondary methods involving molecular weight markers that may be proteins or polymers and measuring their passage using filtration tests and scientific instrumentation to determine the degree of membrane crossover. The ultrafiltration membranes we'll be discussing today are specifically in the form factor of hollow fibers, which are an expansion of our SepraPor tangential flow product line. As most of you are familiar with, these hollow fibers are operated in the tangential flow filtration mode, with the bioprocessing fluid flowing parallel to the membrane surface with a sweeping action that reduces membrane fouling. Hollow fibers have superior performance to cassettes and provide faster processing times and lead to greater process efficiencies, while maintaining higher fluxes and without compromising on product recovery. Today, we'll cover two discussion points for these ultrafiltration membranes. The first one is improved characterization. The second is improved performance. In this characterization section, I would like to highlight the more extensive characterization we apply to our membranes in comparison with another commonly used supplier, identified here as supplier A. SepraPor uses a minimum of 3 molecular weight markers to characterize the molecular weight cutoff of a membrane. Supplier A uses only 1 molecular marker to characterize the molecular weight cutoff of their membrane. For each molecular weight marker tested, we can determine, using a scientific instrumentation, the degree of passage of each marker, shown on the y-axis from 0 to 100. The molecular weight marker used is represented on the x-axis with numbers 1 to 4, with 1 being the smaller, lower molecular weight marker, and progressively increasing molecular weight markers for numbers 2, 3, and 4. For a 300 kilodalton membrane, shown here, SepraPor has a distinct passage range for each marker, while supplier A only has a single broad range. The advantage of using 3 molecular weight markers becomes apparent when comparing additional porosities. For different molecular weight cutoffs, say a 100 kilodalton membrane, the passage ranges at different molecular weight markers are lower and specifically have minimized overlap, shown in red on the left graph for SepraPor. Supplier A, however, has a 100 kilodalton range determined using the same molecular weight marker as a 300 kilodalton membrane, and there is a significant overlap of the passage range. Actually, there is sufficient overlap that it would be difficult to say if this was a 100 kilodalton or 300 kilodalton. Supplier A does not have a clear distinction between 100 and 300 kilodalton in this example, and the use of a single molecular weight marker does not provide additional information about the retention profile, which is how does the passage change with different molecular weight markers. SepraPor, on the other hand, has a clear retention profile based upon the passage behavior of 3 molecular weight markers. Taken together, these passage ranges generate what we call a passage band. These passage bands are unique to each molecular weight cutoff with minimum overlap between them. So on the left-hand side, the 300 and 100 kilodalton passage bands are shown. Again, this cannot be said of supplier A. Supplier A does not have a retention profile that is clear and has overlapping passage ranges for 100 and 300 kilodalton in the example we discussed. SepraPor therefore provides a more in-depth membrane characterization than other membranes on the market. I would now like to transition to the last section of the presentation, where we will cover some of the performance aspects. Now, in terms of performance, we want to highlight how this extended characterization process provides better lot-to-lot repeatability. SepraPor ultrafiltration hollow fibers are manufactured with the aim of having their retention profile match the allocated passage band. Here we show different ultrafiltration lots on this graph that are shown to fall within the passage band for 300 kilodalton. This would be considered as part of our release criteria to classify these lots as a 300 kilodalton membranes for our customers. So we realize this characterization is more demanding, but we're confident that this improves lot-to-lot consistency, and this will translate to lower process variability for our customers. Passage bands can be established for different porosity ultrafiltration membranes, from 5 kilodalton to the largest 750 kilodalton, shown here. For simplicity, are 4 different passage bands. Each molecular weight has its own distinct band with minimal overlap. SepraPor molecular weight cutoffs are defined clearly, reproducibly, and without ambiguity. And finally, we want to highlight that SepraPor membranes have higher flux values and offer typical flux ranges as shown in the graph. Here also, we added the minimum flux for supplier A. So we want to highlight in this particular slide that SepraPor has higher flux values than supplier A, but also offers the advantage of typical flux boundaries. Supplier A, on the other hand, has lower minimum flux values throughout all molecular weight cutoffs, as you can see in the graph. And finally, as a conclusion, I hope we have shown that SepraPor ultrafiltration hollow fibers were developed with higher industry standards, with higher flux values, improved characterization of molecular weight cutoffs using multiple molecular weight markers, and improved lot-to-lot consistency. And I'd like to leave the audience with a take-home message, is that well-characterized membranes with enhanced consistency can improve the performance of a purification process. So thank you for your attention, and if you are interested in ultrafiltration products for your demanding application, we encourage you to visit our website and also to reach out and visit our booth at BPI West. Thank you very much for your attention.